All right, so now we're switching gears a little bit. Number 7, Descartes' rule of signs. This helps you to, I guess, minimize the number of zeros that you would actually have to try. So I'm going to write down the polynomial x to the 4th minus 9x to the 3rd plus 24x squared, and then minus 54x, and then plus 108. Okay. You're going to do two things. You're going to take your original polynomial, which is positive, and then you're going to do n of negative x. So this is the negative one. So when you do negative, the only ones that change signs are the odd degrees. So anything with an even degree, if it's positive, it stays positive. If it's negative, it stays negative. But anything with odd is going to change signs, an odd degree on the x. So that's 3. This is understood to be a 1. That's an odd number. So n of negative x is going to be x to the 4th. And then that's going to change to positive 9x to the 3rd. And even degree is going to stay 2x squared. Odd degree from negative is going to change to positive 54x. And then the 108 will stay the same. It doesn't have an x. All right. So these are your two polynomials that you are working with. Then you have this positive and negative scenario. So what this means is you're going to count from the positive polynomial, the original, how many times the sign changes. So right now it's positive. When I go to the next term, it changes negative. So that's 1. And then from negative, it changes back positive. That's another sign change. From positive goes back negative, another sign change. And from negative to this last term is back positive. So this has changed signs 4 times. All right, 4 here. And then you decrease by 2 and you continue to go down. So once you count the number of sign changes, decrease by 2. And then you keep decreasing by 2 until you get to 0 or negative. And then you stop there. So I can't continue to decrease by 2 because it doesn't make sense to have a negative number of zeros, negative number of times that you cross the x-axis. All right, so let me say, for example, that we counted 3 sign changes, for example. Let's say we counted 3. You would take that number, decrease by 2, which will give you a 1. And then if you decrease by 2 again, that would give you a negative 1. You would not use that one. You would just stop at 3 and 1. Okay, so you keep going until you get to 0 or a negative number, at which point you stop. 0 is possible. So whenever we would do that possible list of rational zeros, so let's just say we did 108, and then we would divide by 1. So all the factors of 108, which I think there are a lot of them. 1 and 108. And then we have 2 and 54, 3, and goes in there 36 times, 36. 4, I think 4 too. 4, 27. But we would keep going. 6 would also be a factor. 6 times 6 is 36. 6 and 18. But we have a bunch of numbers, so I'm going to stop there. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that I found. This theorem is saying that out of the positive and negative, so we just focus on the positive, only 4 will work. Or 2, or maybe none of them will work. So it's telling me that you don't have to try all of these. Not every number is going to be a positive 0. So the biggest I can have is 4, so that means all of them either going to be positive, either 2 of them or none of them will work if I continue to factor this. Now the negative one tells me how many negative zeros I have. So you got to count how many sign changes from here. So this is positive, it's still positive, still positive, still positive, still positive. So this never changed signs. So we have 0. So that means that none of the negative numbers will work. So I don't have to worry about trying -1, -2, -3. I don't have to worry about trying any of those with synthetic division to find my zeros. So this is just helping us maybe save time whenever you're doing all of this completely by hand. So the possible number of positive zeros are 4, 2, or 0. So either they're all positive, either we only get 2 positive, or none of them. And then as far as number of negative zeros, it's going to be 0 based on this rule of signs. Okay, so let's do it again. It's the same thing for number 8. We're going to look at the rule of signs and see how many possible zeros we have. So with 8, I'm going to write down this polynomial. We have g of x is 5x to the 10th plus 2x to the 8th plus 11x to the 6th plus 11x to the 4th, and then plus 3. And then I'm also going to do the negative one, g of negative x. Now remember, we only changed the sign of even degree. We only changed the sign of odd numbers. So 10 is even, 8, 6, 4, all even. This does not have an x, so it will not be affected. So the negative, g of negative x, is exactly the same because that will not change signs. Plus 2x to the 8th will not change signs because it's even. Plus 11x to the 6th will not change signs because the degree is even. Plus 11x to the 4th will not change signs. Plus 3 will not change signs. So when I say even, we're not talking about the number out front. We're talking about the exponent, the power. So they're both the same. How many times does this change signs? It's positive to positive, still positive, still positive. So 0 sign changes. We don't need to go down by 2 because it's already at 0. And then negative is exactly the same polynomial. It's positive all the way down, so 0. So it looks like we're not going to get any rational zeros from this. So they will all be irrational. All 10 of them potentially. So 0 and 0 because we didn't get any sign changes.